Hello, everyone, and welcome to the CADimensions 3D Printing Podcast. We are here today because we refuse to let the coronavirus get us down, and we will still make a podcast despite the current world situation, if you will. We do this podcast once a month where we get together to talk about technology and 3D printing because here at CADimensions, we want to help engineers everywhere to have the best tools possible that then enable them to impact the world. And we think this podcast is just one small way that we can make that happen. My name is Adam Fosnot. I'm a 3D printing application engineer. And joining me today virtually is...
Are you going to give the name?
Kevin.
No?
Kevin, you were first.
Oh, hey. I thought Ken was first. Hey, I'm Kevin Keefe. I'm in marketing at CADimensions.
I'm Ken Postal, application engineer at CADimensions.
I'm Ben. I'm the video guy and marketing.
Awesome. And we also have a very special guest with us. Go ahead and introduce yourself, Andy.
Andy DeLora, Vice President of Sales and Marketing here at CADimensions.
Awesome. I think you're the very first guest appearance. This is the first time we've ever had 5 people on a podcast.
Yeah. I feel very honored to be joining you.
Actually, I believe your brother was on. I think Tom
I feel
was
less
on.
honored then.
You're right. You're
Your
right.
second one.
I think so. You're right.
Yeah.
Oh, man.
Well,
that
nonetheless.
was so long ago. Anyway, we wanted to dive into our first segment where we're going to warm up our brains with a thought-provoking question from Ben. Ben, what do you have for us to discuss?
Okay, so we're all stuck at home, and I don't know about you, but I've been wondering how in the world is everything still going to get done? Like, how are our shelves still going to be stocked? And I was also thinking about how fast the response was from the 3D printing community around the world, creating face shields like this. Not as thick. This is actually what I used to make knives. But face shields like that. And just what does manufacturing look like from a work-home world? Work-from-home world.
That's a good question. I have some opinions on it. I think automation is going to be key as the world starts to become more work from home friendly. I guess by necessity. I don't think we know how long this situation is going to last. And I think remote monitoring and connectivity is something that we don't see a lot in manufacturing today. In terms
You're talking
of
like
machines.
feedback from machines and understanding when you have downtime or you have breakage or you have stoppage and stuff like that from a remote monitoring standpoint.
Yeah. So from my understanding, at least in a lot of places that we go, they have machines that are over 100 years old. And they've been running them since World War II. And those machines are definitely not internet connected. And so it can be hard to monitor machine, like you said, uptime, downtime, and how much you're actually creating.
Interesting. I wonder what there are a lot of stories about companies that are making adjustments to, they're essential businesses. So they're making adjustments to their practice to include social distancing policies with people on the production floor, stuff like that. I wonder, Andy, do you have any perspective on anybody, in our local territory of, the New York Northeast area companies that you've heard from that are making special accommodations, or how are they getting through it?
Yeah, I think the most common thing we've heard of is enforcing more shift work. So places that used to do a 1 8-hour shift are now doing 3 shifts with less people on the floor at a time to encourage social distancing and to practice, I guess, some safer measures. We're also hearing a lot of companies that are shutting down for an extended period of time to do some deep cleaning. So I've heard a couple customers that are shutting down, in the evening time frame and bringing in cleaning crews and doing deep disinfectants on a daily basis, whereas they might not have been doing that as regular in the past.
What a nerve-wracking time to work for like a food processing, like a General Mills or something like that, where you're so heavily involved in affecting potentially millions of people from your workstation. Interesting.
What I find even more interesting, though, is just how fast we're able to create those face shields. If we didn't have 3D printing and we just had to either do an injection mold or some milling, whatever it was, I mean, that's not something you can do immediately. But the other thing is we have an entire community that has printers in their living room, Adam, and I don't see that many people with a CNC machine in their living room. It's just the entry level for cost is just so different. And I think on a further, like a longer scale thing, obviously you can't 3D print every single face shield, but trying to get them boots on the ground, trying to get them happening immediately, it was amazing. It was like 1 week. All you do is email a file to all of your colleagues, and boom, you're making a bunch of them. It was so cool to see.
Yeah, I think that that network aspect of it is also really cool. It's I think often referred to as like a distributed manufacturing model. And I think that that's where a lot of these issues came from, is that the virus started in China, and China is the world's factory. That's where pretty much every single thing is made. And so they shut down for longer than they would normally over the New Year holiday. And then at the same time, you had a massive demand for manufactured products like the N95 masks. And so those kind of compounded on top of each other, where, you know, the supply chain was just completely decimated. And that's where a flexible manufacturing platform like 3D printing, because it doesn't have any molds or tooling, can really step in to fill that gap.
Yeah, I think the key thing to focus on is that filling that gap. I've heard hospitals asking for as many as like upwards of 350,000 of these masks by the time this is all over, and that's one hospital. That would take an army of 3D printers to come close to that number. So in the short term, while we figure out how can we get our injection molding, our urethane molding up to speed, it is a valid option for the short-term supply chain. I think we talk about, we were making masks ourselves, and I know some of our customers have finally got up and running so that they can injection mold and urethane cast these pieces themselves. And obviously they'll be able to do it at a scale that we can't touch.
Yeah, but even still, I think we've seen local companies pick up injection molding for these face shields, and that's a testament to the distributed manufacturing model that I think we'll see continue to grow over, especially the next few years as everyone kind of tries to recover from this. Is that I would expect there to be an increased focus on made locally, made quickly, made custom. Those are all things that 3D printing is great at, but that is really what we needed in this situation.
And so, but it's interesting you say that, because for so long that has been what people are talking about, is the evolution of moving to something where everything is custom, everything's made to order, everything is, you can create, whatever you want. But it might take something like this where everybody has to adapt and adjust in a way to overcome this. And when you come out the other side of it, then doing things like that are way easier to do, because you've had to build all of the templates in place to stand you up to do that. Kind of like we were talking the other day, my kids will never have another snow day. There's no reason to ever have another snow day, because everybody has the capability to do school from home now. So really, you might never have to have one, but you might also never have to just buy something off the shelf, because you can customize whatever you want, because all these companies are going to have to be nimble to accommodate, getting through this.
Don't tell your kids that.
I know.
Kevin, it's funny. I heard this about a month ago, so before all this happened, but the reason most U.S. companies provide health insurance for their employees goes back to the end of the Great Depression, the end of World War II. Companies looked at that as a way to competitively differentiate themselves against each other, because there was such a demand for workforce. So they said, all right, there's more jobs, or more people than we have jobs for. No, take that back. More jobs than we have people for. And in order to get the best talent, they had to give them something more than just a salary. And that's where benefits came in. And now, 60, 70 years later, it's like a no-brainer that every company provides, or most companies, I should say,
right,
provide benefits. And I'm curious to see what that thing that comes out of this, world-changing affair is going to be. And if it's on-demand manufacturing, I don't think that's a bad thing.
And is that something that CADimensions can take part in?
On-demand manufacturing?
Yeah.
We can sure as heck help support it. Yeah, I think that's what, our bread and butter of the products we offer and the services we offer are geared toward helping manufacturers and designers do stuff quickly and efficiently. So absolutely, I think that's a big part of our future going forward.
And one thing that I think that we're going to take back from China is I saw some child labor going on at your house, putting some of these face shields together.
That was child volunteering to help a good cause, Ben.
Oh, okay.
Well, so what I think Ben was talking about before, because, he and I being in the marketing space, we have maybe a different optics on it, but I think we were talking about the reaction of the maker space, like the maker community, to say, like, here is this this problem that faces the society. How can we contribute? How can we help? And the maker space community just volunteered everything they had. Let's go. Let's start making these shields. Let's do whatever we can. And I think that the outpouring of that was just a really positive light in all of this darkness.
Completely agree. I think the collaboration between the community and especially, as you said, the maker community has just blossomed in this pandemic, and it's really inspiring and pretty cool to see what can be accomplished when one person throws an idea out there and then it just kind of compounds on it, and people put in their input and people start manufacturing or printing in this case, and I think the printing community has done a really nice job of helping to bridge that gap between a critical need and when products can be mass produced.
So Andy, this kind of leads into our next topic, which is why we wanted to have you in here to talk about what specifically is we've talked about with the makerspace community, and obviously CADimensions being a service bureau. We have machines on staff. What has CADimensions been doing to help fight the COVID-19 battle?
Yeah, so we've taken a couple different approaches. One direct approach is we started printing visors and we sourced plastic polycarbonate for the face shields almost 3 weeks ago. So
it's pretty quick.
In that time, as soon as this stuff started happening and some word got out there that this could be done, to the credit of our amazing team, they jumped at it and said, "Yeah, we can do this." So we've been kind of on the front lines of producing the face shields. So far, we've gotten about 500 of them produced and allocated to hospitals across New York State, down in Long Island, in Massachusetts. We've sent some to. So I'm very proud of what our group has been doing to help equip the front lines in fighting this pandemic. Actually, I can share with you guys today, as of about 2 hours ago, we got word that we actually could find some more of the plastic sheets out of a distributor in New Hampshire. So we ordered more plastic sheets and looking to ramp back up and do another 500 or so face shields probably within the next 2 weeks.
That's awesome. That's fantastic. And I don't want to, look away from, obviously, Ken and Adam are a part of that team that helped to contribute to the creation of those shields. So kudos to you guys for being on that team, and thank you for your efforts. Andy, where do you see this going in the next 30 to 60 days? So you were just talking about how we're sourcing more materials and we're going to be able to print some more shields. Where do you see, either in our community of manufacturers or within CADimensions, where this is going to go in the next 30 or 60 days?
It's a good question, and I think it's changing by the minute, it seems. But I'd say confidently in the next 30 days, we'll continue to rely on the maker community, and we continue to contribute to that. Of printing the shields and trying to help out where we can, again, and bridging that gap. We have gotten word, a few of our customers, Cascade Lacrosse, PPC, R&D Design, Century Mold, a lot of companies out there are mass producing face shields now. So I think that's going to reduce the reliance on the 3D printing of them and the maker community of them, which is a good thing, right? Our job there, I think, was to bridge that gap, but now that we can mass produce them at rates that are a heck of a lot faster and much cheaper that can be done on the 3D printing side. So I do think that other manufacturers that are not in the business of making face shields are going to jump on that and start doing what they can to help out. And hopefully this crisis becomes a little bit less severe for those on the front lines.
A lot of manufacturers are being, not just here locally, but nationally are being asked to do a lot of things that they weren't, 30 days ago. So, yeah, it's interesting to see how that continues to take shape.
Great point. And I think we've been talking a lot about face shields because that's the one area that we can contribute with 3D printing. But you're hearing the same thing about ventilator components or ventilator manufacturers. Actually, I just got word today that the Tesla factory in Buffalo that we support is converting their lines over to manufacture ventilators. And
that's great.
Actually, another customer of ours, Medtronics, who makes ventilators, said, here's all of our CAD data, here's all of our assembly data. It's open to everybody.
I saw that.
If you can make these, go ahead and make them.
That's awesome.
Which I think is unbelievably generous and so cool to see the humanity come out in something like this.
Yeah. That's awesome. Thank you very much, Andy, for your input, for stopping by, for joining us, and fun to have you on. I appreciate it.
Yeah, likewise. I appreciate the invite, and thank you guys for continuing to help CADimensions operate and support our customers in a remote setting. And again, kudos to Ken and Adam for their participation in helping to make so many of these face shields.
Thanks,
Andy.
I've gotten used to working from home now. I mean, I don't get to work.
It's not
from
as
a
bad
bed.
as I thought it would be.
Yeah.
It's not as bad as I thought it would be.
Yeah.
The first week was a shock to the system, though.
Right. I agree. And we kind of joked about it. What's going to be that big change after all this is done? I could absolutely see that especially for companies like ours, right, that need for brick and mortar office space becomes a little bit less important because we can be as productive and as efficient without it.
I think personally, we should just take everyone and have them work remotely and then buy more and more printers for the lab. Just make the whole office is just a lab. Just throwing it out there. You never know when the next pandemic is going to hit, and we're going to need that quick turn whole bank of printers ready to go.
I'm going to keep my comments to myself, Adam.
That's probably for the best. No, but it's been fun getting to print some face shields at home. But I'll tell you what, after a while, the noise of having the printers running in my living room does tend to get to me after doing it for a few weeks and starting one print after another.
Well, we owe you some drinks and maybe some earbuds too then.
Yeah. Earplugs would be very welcome.
Yeah, I ended up taking one half day off of printing just because I had to make the machine stop. I couldn't be in the same room as it and work.
You two obviously are not parents.
No.
You develop a real tolerance for incessant noise.
Again, my apologies if you hear a screaming baby on the other side of that wall.
It's a bingo at this point.
Basically. So this is like parent prep for you guys.
That's right.
It's a noise that you can't stop or shouldn't stop, and you just have to deal with it.
3D printers are basically children. That's at least the ones we have at home. Is the moral of the story. All right, thanks again, Andy. You're welcome to hop off, and we're gonna
you're a busy
run
guy.
through our next two segments. We know you got a lot going on.
See you, Andy.
Thanks, guys. Appreciate it.
Thanks. But that brings us to our next segment. Ken is going to bring us the 3D printing application of the month. What do you want to talk about, Ken?
Sure. So last week we talked a little bit about functional prototyping. So I wanted to do another more functional topic this week again. Wanted to talk about fixturing, so jigs and fixturing, and specifically why companies are looking to additive to make these things. Traditionally, a lot of jigs and fixturing have just been done using just machine components or plastic injection components, but why they're specifically looking to additive, and then on top of that, talking about a couple specific cases that are unique to additive and reasons why companies are using specialized materials for their jigs and fixtures. So the first one, I guess, more of a question would be, Why do you think people use additive for this as opposed to just traditional methods?
Probably for the customization. Sorry, I'm not bad.
For jigs and fixtures, or
Yeah, jigs and fixtures.
well, it does free up use for your big machines for so you don't have to take them offline to create a jig or fixture.
Yep, that's one part of it. So basically taking non-customer or non-value added tasks off of your CNCs and your other manufacturing machines. Kevin, do you have
I was going to say customization, right? So, I mean, your product is going to change. So if your tooling doesn't change to support it, then it's not going to be very functional. So I would imagine having flexibility would be a big benefit.
I've got
that's
one.
definitely a big reason.
I would agree with that, but I would also say that something we haven't touched on is just sheer capacity. If you have a dedicated tool room and dedicated employees who work full-time in that tool room, they can pretty quickly get overloaded just with requests from different departments. And so having kind of like an extra set of hands that you don't need to physically be there working the machine to make something, I think is a huge benefit.
Yeah, and I know with my last employer, it was a factory setting, and for that machine shop, there was about a 3-week lead time on almost everything out of the machine shop. So basically how I got any of my prototype fixtures out was a bag of combos to convince the machinist to stay an extra 30 minutes. And that was for every single one of my prototypes.
Did you just buy combos in bulk after a while? You just go up to Costco, get a huge pallet, and then anytime
Are those the
you need
ones
one,
you
you
stick
just
on your
hand them
fingers?
No, those are bugles, Ben.
Oh,
Those
bugles?
are bugles.
Not your snack chips.
I was just picturing a machinist with his fingers covered in bugles, but
No, never bought in bulk, but I was getting close. But there was a lot of Funyuns and combos exchanged for parts.
You gotta do what you gotta do. Honestly, I think a bag of combos in exchange for half an hour of overtime is probably a pretty good deal.
What okay, so I'm going to feign a little ignorance here, and I may get shouted on the comments later, but that's okay. Can you roll through some examples of jigs and fixtures? Like, I know drill guides and, bracket holders or things like that sometimes, but what are like some of the most popular examples of like jigs and fixtures?
The most common one that would pop first in my head is like an assembly aid. So whether that be something to hold a component or to, I guess, kind of guide an operator to do something correctly. I know a popular one I worked with in the past was like a welding fixture. So if you had to weld two components at a perfect 90-degree angle, you would put it in a fixture, not like gas. You're not holding the two pieces up while you're trying to weld it. You just place the two pieces, clamp them into the fixture, and then perform your task. That way you're always getting the right angle.
Sure. Okay.
A lot of fixtures are like that, where you're forcing some level of quality by using the fixture.
I just wanted to make it real for a second. I feel like we use the terms jigs and fixtures really loosely in application, terminology, but I feel like it warrants diving like what is that specifically?
Kevin, I got another one for you.
Please.
Vice jaws.
Sounds terrifying.
yeah.
It does kind of sound terrifying.
Then you don't damage the piece that you're working on.
No, vice jaws is in case Jaws gets caught, then he's the new Jaws.
Not the shark. Not the shark.
Hey.
Boo!
I
Kevin,
thought the comments were going to be bad before.
I know, right? Yeah.
Kevin,
that's
did you
okay.
just come up with that now?
I did, on the fly.
Nice. I like that. I like
Thank
that
you.
a lot. I might steal that next time we're talking to customers about this sort
About
of
vice jaws specifically, you're welcome to.
Yes.
Freelance.
But in machining, vice jaws, say you go out and you get a casting made, right? You only get castings made when it's more efficient than machining away from flat stock, bar stock, rods, whatever that is. So then now you have this complex shape, but you need to do post-machining on it for your critical surfaces. It's a weird shape, which means you need custom jaws so that you can clamp it in place in your CNC machine so that it can cut away the critical surfaces. 3D printing is a great application for that because it's a complex shape. Like Ben said, it doesn't scratch the surface of the workpiece because it's made out of plastic. It can be made quickly without a machinist having to take time away from another job. It's a great application.
That's a cool
something we talked
application.
about with another customer was laser marking fixtures. So you have a part, you want to put it in your laser engraver, and you need something to hold it. Again, assuming it's not just a flat sheet of something, you need something to hold it in place at the right angle so that the laser can go and engrave a part number or anything else on it.
I saw that on Shark Tank.
What?
There was, I saw that not exact, but something like that on Shark Tank, where there was this company that was getting 50 caliber shell casings, and they were turning them into beer bottle openers. And they had a laser engraver, and they were putting like one shell casing at a time on it. And then they made a fixture where they could put like 100 on their laser engraver at a time and do 100 at a time versus just one. And they thought that they would help the problem before they made the fixture, and they bought like 4 more laser engravers. So when they went on Shark Tank, they're like, why do you have so many engravers when you have such a big tray and you're doing one shell at a time? So that was a great example.
That is a perfect example, actually, because if you think of like a shell casing, it's not a flat sheet that just easily goes into the laser cutter and you can cut out a bunch of parts. It's rounded, it's thicker at one end than it is on the other. 3D printing a fixture for that so you can line up 10 or 20 shell casings, hit go on the job, and come back in 30 minutes, hypothetically, instead of 30 seconds because you were only doing one shell is a great fit for a fixture.
Can you imagine that mind-numbing job that guy had before the fixture? Just staring at a laser engraver all day long when he could have just had a fixture?
I really can, actually. I used to run a makerspace in college, and we had a laser cutter / engraver, and I would regularly stand there and place things in the laser engraver and hit go and then run back to my laptop, send the next job over, hit go. Yeah.
You needed a fixture.
I did. I needed a fixture.
A big part of fixturing is ergonomics. So protecting workers from having to move in awkward ways or put torque in odd angles. That's a good way to prevent your company from having to pay higher and higher injury claim bills. So there are some companies that strictly use fixturing just for the ergonomic aspect.
That's a good point.
I think the second part I wanted to talk about was specialized materials. So when we talk about specialized materials, there's different types of fixtures for different industries. So some of the most common, and one of them you guys already brought up, but the first one is those non-marring fixtures. So when you're dealing with objects that have painted surfaces or highly finished surfaces, you're trying to find a fixture that won't damage that surface after that paint or finish has been done. The second one that I think is probably the most common for us would be ESD capabilities. I don't know if somebody does anybody know what ESD is?
I do.
Kevin, go ahead.
Electrostatic dissipation.
There you go.
Did you really know that, or did you look that up?
Yeah, no.
Ahead of that. I've never heard of that.
I sit through the webinars, Ben.
Webinars, yeah.
Oh, I don't do those.
All it really is for companies who are manufacturing electronic components, so think of like PCB boards, the fixture allows charge to pass through it to a grounded surface. So that way with a traditional fixture, what might happen is if a charge is created or given to the board, a insulator would pass that and ruin a component in that board. So by using ESD components, we're allowing that charge to dissipate. And then the last one was the chemical resistance. And I know we talk about some of our higher level materials like the Antero or the polycarbonates or Ultems. I know you see those in the aerospace industry, but I even saw one customer example I can think of as a paint company was looking to make fixtures that could survive MEK. So just being exposed to that chemical for long periods of time.
I know that one too, Ben.
I don't.
Kevin, what's MEK?
Ketone.
Methyl ethyl chloramide.
Ketone.
Ketone.
Methyl ethyl ketone.
It's nasty stuff. It's really caustic.
I
So
usually
it's a nail
explain
polish remover.
No, far worse than that.
Yeah, I usually explain it as like super gasoline. Like
Yeah.
it's really nasty. It'll burn your skin off.
Yeah.
Don't play with it in the backyard.
But if you can 3D print something that will not resolve, this is all the way in that, right? Is that what you're saying?
Yeah, so ironically, with materials like, I believe our Intero, which is the PEC-based material, it actually gets slightly stronger when exposed to MEK, which I found rather interesting.
It's like a super villain.
Don't ask me why, I don't know why that is chemically, but its performance actually slightly improves when it is exposed to that chemical.
I didn't know that. That's pretty crazy to think about.
Yeah. Chemistry's weird anyways.
It is. But there are some applications where even like metal fixtures react badly with the processing chemicals that you want to be able to use. Like if you're using an acid etching thing, plastic might resist that better than a metal fixture. And so it makes sense to print them.
Yeah, and then ultimately there are cases where just metal is still the go-to. So like if you have high wear and tear on fixtures, I mean, beyond what's capable with your Ultims and PCs, yeah, they still make sense sometimes. So it just depended on the situation.
I think that brings us to our next segment, you guys.
Thank you, Ken.
Thanks, Ken. That was a fun conversation.
Anytime we can talk about methyl ethyl ketone is a good time. So
Well, you said it's a super gasoline, and now that gasoline is getting so cheap, maybe I'll have enough money to play with it.
I'll tell you what, I am so happy with how cheap gasoline is, and also I'm not using it as much because I'm not going to the office as much. So like I bought gas at the beginning of March and at the end of March, and I still have like a full tank ready to go from when I bought it at the end of March.
I bought gas at the beginning of March, and I haven't bought it since, and I still have like 80 miles to go or something.
The irony that
Haven't gone
gas
anywhere.
is cheap and we can't go anywhere.
Yeah.
Well, that's actually my wife and I, to keep our sanity with our children. We take a roughly 20-minute drive a day to nowhere. We just like see a new mountainside or do something like that, go hiking in a new place. And right before all this isolation happened, we bought a Suburban, and I am loving it. Gas is so cheap. I fill it up and I'll accelerate. I'm like, I don't even care. If it's 1 mile to the gallon, it still is not affecting my pocket right now.
It's true.
Not for long, but
But anyways.
yeah.
Anyways, our next
Side
segment,
story.
you guys. This is my segment, and it's the 3D printing tip of the month. And kind of going off of Ken's fixturing, something that I don't see a lot of our customers doing is pausing their prints to change colors. And so when I go into a lot of facility tours, people will have fixtures cut out of metal and scrawled on them in Sharpie, which looks amazing, and you can always read their handwriting, is like the part number of the fixture. And they have shelves and shelves full of these things, of fixtures and tooling. But when you go into 3D printing them, you don't have to just use Sharpies. I mean, you still can if you want to. But a little bit more elegant way of doing it is you can easily add pauses in your print in GrabCAD, and then you can swap out filaments. And so if you're printing a black fixture, you can put white text on it with 3D printing just by changing the filament, and then that way it's like a permanent melted to the fixture labeling, so that everyone can read it. It looks more professional. It's a good thing that you guys should do.
That's actually
cool.
displayed on our regular podcast location, right next to the 450, on that little cart. Is that what you're talking about? I think
Yeah.
that there's white lettering on that black bin, right?
Yeah, so that's a project that I did, I don't know, probably a year ago, at this point where our process for changing tips over in the Fortis, you change tips every time you change materials to prevent cross-contamination of the plastics, if no one out there knew that. So we were very unorganized with how we had our tools. Sometimes they would end up at someone's desk. Sometimes they would end up, on different tables and different surfaces. And I wanted to try to fix that. And so I made a nice little cart organizer. That way everything has a labeled location that you use to change tips and do the XY calibration process for the Fortis. And Ben will take the editing work of putting some pictures of that in the video.
Why are you giving me more work?
Thanks,
I was just going to let everyone imagine it.
No, I know you better than that. You want everyone to have a really good picture of what this concept is. I actually drew up a sample fixture when I was in the office earlier today, and I took some screen captures of GrabCAD as I was adding the pauses and stuff. So if you're really shooting for the stars here, maybe you'll edit that in. If not,
I can share my screen right now. No, that's a terrible idea.
It doesn't do much for our audio listeners though, so I'll leave that up to you whether or not you think it's actually worth putting in the video. Maybe it warrants a separate tips and tricks video.
All right, for our listeners at home. Close your eyes and picture a 5,000-pound 3D printer, and that's basically what you'll see. Okay, Ken.
Well, the other thing that is really popular when I teach the pause function in some of our printing classes is beyond just color, but inserts. So I know you had mentioned that before, you wanted to talk about that, but when we talk about like those drill guides or anything that's going to have threads, and the threads are going to be repeatedly used over and over, can you tap into plastic? Yeah, sure, you can do it. Is it something I want to be like taking a screw out, putting a screw in, taking a screw out, putting a screw in on that same plastic thread? Probably not. So where pausing features could come in handy is like potentially embedding a bolt or embedding a threaded insert if it's in an odd place. I mean, stuff like that too.
Yeah, I agree. The other one that it's this exact same process as doing an insert, but magnets, if you have parts that need to kind of loosely adhere to one another, magnets are a really popular one. Probably the most popular is putting a nut into a part, and then you're going to bolt it to another part at a separate time in your process.
I've seen some electronics, but the only problem with that becomes good luck getting it out if something breaks.
Yeah. I think bolts for fixtures and color change labeling for fixtures is a lot more practical for probably most of the people in our viewership. Maybe, I don't know. If you are watching this,
is there a danger with putting a magnet in? Like, will it fly up and like attach to your printer?
So we did have one case specifically with our machines. Small magnets that you can get like at the store that you put on like a fridge or a chalkboard, not a problem. I did have one case where I was talking with a company that wanted to use super magnets and embed those in parts. Now, the build tray on most of our machines is metal, so we don't know if it would damage the machine, but good luck getting the part off the bed.
Yeah, I didn't even think about the print bed. I was more thinking of the print head itself.
Yeah.
And my first thought,
yeah,
everything's made of metal. My first thought was it's stainless steel tips, and so it probably wouldn't, depending on the grade of stainless, which I don't know off the top of my head. But
yeah, I know that some stainless are reactive and then some are non-magnetic, but so I guess it depends. Okay, what's the worst case scenario for adding a magnet?
Ken, I'm leaving this one up to you, man. What's the worst case scenario imaginable? Say you put just like a 50-pound neodymium magnet in your print, and you're reckless, so you don't even put like a little dab of super glue on the print before you press it in. What's the worst thing that could happen?
You break your printer? I don't know.
You could break your printer. Don't do that, Ben. You heard it from 3D.
I had to go look up neodymium.
Neodymium.
I did not know how to say it. Neodymium. That was my guess, but
That's why I'm here, guys, to bring the really important parts of this podcast, like saying names of magnets. That's my contribution to the world.
I look to you for heightened vocabulary.
Well, as an engineer, and engineers aren't typically known for their vocabularies. It means a lot to me, Kevin. Thanks. Okay, everyone, thank you so much for joining us for this month's CADimensions 3D printing podcast. If you enjoyed this, make sure to share it with all of your friends and family. I'm sure they would love to hear about 3D printing also, and all about what we're doing for the coronavirus outbreak. Make sure to like this video and subscribe to our channel. Subscribing is free if you guys didn't know that, and then you'll get little notifications whenever we publish a new video so that you don't miss the next podcast. Thanks for watching.
Stay
have
safe.
a good day, everybody. See ya. That was pretty good.
Cut.
Cut.